All right, in this video, we're going to be looking at a circle with a lot of locations indicated on it. And I want you to try to label each of the angles with both the radian and the degree measure. This is kind of getting us ready to be doing the unit circle a little bit later. All right, and so I'm going to go ahead and do a little bit of it. Then I want you to pause the video and finish it and then check to see if you got it straight. Okay, so I think it's pretty good to start with to label the quadrantal angles. So like this would be 0 degrees, this would be 90 degrees, this would be 180 degrees, and then down here at the bottom, see if I can move that up a little bit, that would be 270 degrees. Okay. All right, and let's go ahead and do the halfway in between each of those. So then wouldn't this one be halfway? So that'd be 45 degrees. This would be halfway between 90 and 180. It'd be 90 and an additional 45. So that'd be 135 degrees, right? And then here would be 180 and 45. So that would be 225 degrees. And then this one would be 270 and 45. So this would be 315 degrees. Okay. All right. So we're looking at the angles that are related to these spots right here. Okay. Let me kind of color those spokes. Think of them like the spokes of a wheel in red. All right. Now let's go back and look at what the radians would be on a couple of these. All right, so if I'm trying to do the radians on the locations that you see where the red spokes are, what you might want to notice is that I have 1, 2, 3, 4 equal spots there. And so I cut pi, this is pi, isn't it? We already know that. I cut pi into 4 equal spots. So this should be equal to 1 pi over 4, okay? This should be equal to 2 pi over 4, which is pi over 2, and that makes sense. This being cut in half, pi being cut in half, right? And then this one would be, so this is 1 pi over 4, this is 2 pi over 4, then this would be 3 pi over 4. Okay, that's this spot right here. Let me get those highlighted in red. Okay, then this would be 4 pi over 4, which reduces to be 4 pi over 4 equals pi. So this would be 5 pi over 4. Okay. This would be 6 pi over 4, which simplifies to be 3 pi over 2. And again, that makes sense because you could count it as 1 pi over 2, 2 pi over 2, 3 pi over 2. And then this would be 7 pi over 4. Okay, and then we'd be back around at 8 pi over 4, and 8 pi over 4 would equal 2 pi, and 0, once we get all the way around, is the same as 360, and so you could talk about it being 0 degrees or 1 full revolution, 360 degrees, or you could think about it as being 0 radians, 2 pi radians, okay? All right, so that's kind of the idea behind labeling this. Now, what I want you to do is just pause the video and see if you can go in and label maybe the other marks, okay? So I'm gonna do those in a different color. Let me do those in that bright blue, okay? So I want you to think about this. And let me just highlight those now in bright blue. And I want you to go counting around, trying to label these spokes, okay? All right, the ones that are now in blue. So kind of superimpose the blue on top of it and see if you can get all of those locations labeled. And let's start with the radians and we'll go back and do the degrees later. Okay, so I'm going to get you started on it because I want you to notice that we've cut it into 1, 2, 3, 4, 5, 6 equal pieces. we cut pi into 6 equal pieces. And so this would be 1 pi over 6. All right, so this would be 2 pi over 6, which is the same as 1 pi over 3. All right, now keep going, counting all the way around, and see if you can get all these other locations labeled. Okay, so stop the video now and finish up, and then come back and see if you did it okay. Okay. All right, so now you're back and you're wanting to just check to see if you've done it correctly. So you see this would be 3 pi over 6, but that would reduce to be pi over 2. This would be 4 pi over 6 right here, which would equal 2 pi over 3. Okay. This right here would be 5 pi over 6, and that doesn't reduce. This would be 6 pi over 6, but that's the same as pi. This blue one would be 7 pi over 6. Can't simplify that. This would be 8 pi over 6, and that would wind up reducing to be 4 pi over 3. This would be 9 pi over 6, and that would wind up simplifying to be 3 pi over 2. This is 10 pi over 6, which is 5 pi over 3. And then this would be 11 pi over 6, which doesn't reduce. And then this would be 12 pi over 6, which is 2 pi. Okay, to see how we can get those labeled by doing counting kind of like on the number line. I want you to get used to that. It really helps. And did you notice how some of these turned out to have denominators of 3? Okay, so let me get a green color and kind of emphasize those and see why they turned out the way they did. See, here was 1. Here was 1. Okay, here was 1. And here was 1. Okay, so if you look at the green marks, you could think of those as cutting pi into 1, 2, 3 equal spots. And that's why this was 1 pi over 3. This was 2 pi over 3. This was 3 pi over 3, which would be 6. This is 4 pi, the location of 4 pi over 3, 5 pi over 3, and then this would be 6 pi over 3, which reduces to be 2 pi. Okay. All right, so I think it really helps to just get used to how to count, find where you're located in radians by just counting. All right, and then let's go back and do the degrees real quick. That doesn't take quite as much time. I think you kind of understand that more typically than the other. All right, so let's look at putting the degree measures on here. So the blue lines that we had originally broke 180 into 6 parts. So that means each of these little segments right here are like a rotation of 30 degrees. So this would equal 30 degrees. This would equal 60 degrees. This would be 90 degrees. This would be 120 right here. Okay, this one would be another 30, so that'd be 150 degrees. This would be 180. Then we'd be at 180 and 30, that's 210. Okay, this right here would be another 30, so that'd be 240 degrees, and then see 270. Okay, another 30 would be 300 degrees, that's right here. And another 30 would give me 330 degrees. And then another 30 would get me back to 360 degrees. Okay, so let's do, I think we could maybe do a little bit more on this video. I want to look at something called a coterminal angle also. Okay, so let me go down to the next page. All right, coterminal angles. What happens is sometimes you rotate in such a way that you have a negative degree measure, or sometimes you rotate like all the way around more than 360 degrees and you keep wrapping around. So a lot of times we want to take an angle like the 480 degree one, and we want to write the degree measure for an angle that would have the same terminal side. So coterminal angles, they just have the same terminal side. Okay. All right, so like a coterminal angle, for 480, we could find by just, 480 did this. It went all the way around 360, and then, okay, and then it wrapped around, continued around another 120. So it wound up being about right there, okay? All right, and so what it means by writing down an angle that is coterminal to that, we would say 120 degrees would be an angle coterminal with that one. And they wanted us to come up with a positive angle that was less than one rotation, okay? So when you have this one, you can kind of picture where you're at. You've gone in the negative direction, clockwise, 132. So you've gone past 90 over to here, okay? All right, so this one's a little bit tricky to do, I think, because we got to come up with a positive one. So, this was 90, and then you went another 42 degrees here. Okay, so to figure out what you've got, okay, we're trying to come up with what we would call this angle if we went in the positive direction, that many. Okay, so we could kind of think of it as 180 plus that little gap right there. So if this was 42, then that would have to have been 48. Okay, now kind of an easy way to do it is just to add 360 to that. All right, so when you add 360 to that, you wind up getting 228 degrees. 228 degrees. So that'd be 180 and another 48 would get you to 228 degrees. So it's like we're naming, the angle is actually different because it's a different rotation, but in a lot of ways it's the same because it had the same terminal side. And so when you talk about doing the sine, cosine, or tangent, that angles with the same terminal side will have the same sine, cosine, or tangent, okay? All right, so with 855, we've rotated around several times. So you might just subtract off a couple rotations. So if you take away one rotation, you'd be at 495. If you unwrap it a little more, you'd be at 135. And so that would be an angle that would be coterminal to that, would be 135 degrees. Okay, 228 here, 120 there. All right, and then 21 and 22, they're in radians. So there you have to kind of think about how a whole rotation is 2 pi. And then remember our work with fractions. Here the denominator is 5. So think about how 2 pi in terms of fifths would be 10 pi over 5. So what I want to do is I want to take away a whole rotation. I'm going to take away 10 pi over 5, and that's going to mean that this angle is coterminal with 3 pi over 5. Okay? All right, with 17 pi over 3, I'm looking at how the denominator is 3. So what I'm going to do there is I'm going to be subtracting off rotations. 2 pi in terms of thirds would be 6 pi over 3. And so I could take away 6 pi over 3. Okay, and I'd be down to 11 pi over 3. Okay, let me start with 11 pi over 3. And I could take away 6 pi over 3 again, and I'd be down to 5 pi over 3. And that would be the angle coterminal with that one. All right, and then 17.4, that is just a number that's in radians. And so there you might want to kind of remember that 2 pi is about 6.14. And so what I'm going to do is actually just use my calculator, and I'm going to subtract 2 pi, or I'm going to subtract the 17.4. Take 17.4 minus 2 pi. Okay, and then I see that I'm still bigger than 6, so I'm going to subtract another 2 pi from that. See, this gets me to about 11.12. going to subtract another 2 pi. Okay, and I'm going to be at 4.83 about. Okay, and if I rounded that to the nearest hundredth, that's what I would say. Nearest tenth would be 4.8. You know, what you round to kind of depends on what you're using it for. So that would be an angle that's less than 2 pi. 2 pi is really 6.14, so it has to be less than 6.14. Okay, this is a good place to stop, and then we'll have one more video that looks at applications of what we've been learning. So let me stop